Hi, my name is Siti Husna Binti Noor. My metric number is 200,982.
Assalamualaikum, my name is Najwa Azira with Murad with metric number 20371. Every house is equipped with front lighting. Sometimes people do not care whether their entrance lighting is turned on or off all day. People tend to forget to turn off their front yard light even it is in afternoon when the sunlight is shining on the sky. And people sometimes forget to turn on their front light and cause total darkness that attracts people with bad intention to rob their house. Automatic lighting control solves this problem. It is an easy to use and convenient solution that will make your electric bill decrease than before. Automatic lighting control reduces the energy usage as it turns off by itself when they are not needed. PIC microcontroller will generate the control signal after analyzing the amount of light. In this project, light dependent resistor (LDR) will act as a light sensor that sends the light intensity from the sunlight and change its resistance value. If the light intensity is high, LDR will have low resistance and the entrance light get dimmer and vice versa. List of hardware and software that we use in this project is PIC microcontroller, crystal oscillator, resistor, capacitor, LDR, 7-segment display, N-channel MOSFET, diode, 12-volt battery, inductor, 12-volt lamp, relay, power supply, 12-volt, diode, and NPN resistor. For software, we use NPLab X IDE V5 version 5.5 for the coding and produce it professional to get the schematic diagram and PCB layout. The system flow diagram start with the sensor detecting light intensity of the sunlight. It entered the condition. If intensity is the highest, figure 3 will be displayed and the lamp brightness is maximum. If intensity is moderate, figure 2 will be displayed and the lamp brightness will be medium. If the intensity is low, figure 1 will be displayed and the lamp brightness will be low. So if the intensity is almost zero, figure 0 will be displayed and lamp will be off. All these instructions will go into the loop, goes back to the sensor detecting light intensity. This project will be in continuous loop with no end.
For block diagram of this project, microcontroller input port is connected to LDR and buck converter 4V. For the output port, it is connected to 7-segment display and relay connected to lamp. For the schematic, we are designing the circuit using Proteus. There's addition of crystal oscillation and buck converter circuit. So I will explain the operation how it's work in the next part.
Next is PCB layout. As you can see, this is the PCB layout on the figure shown. At the center of the figure, we have the PIC microcontroller connected to the resistors for the 7 segment and connected with power supply and so on.
For program flow diagram of this project, the program is start with an oscillation frequency of 20 MHz, the MR2 per scalar value is 4, PWM frequency is 5 kHz, ADC value is set as 0, and port A is defined as input port, port B and C is defined as the output port, and then call the function ADC initialization. So in this function, ADC on 0 register and ADC on 1 register is configured to get clock select bit, frequency oscillation is divided by 16, and then call the function PWM initialization. So in this function, we will set PR2 value to 249 and configure CCB1 module with timer 2 module. Next, enter the Y1 loop. So in this loop, ADC value at channel 0 is read. So proceed with calling ADC read function. Firstly, we clear channel select bit and set analog channel select bit to channel 0 and ADC conversion is started. Next, ADC value is being compared into 4 conditions. The first condition, if ADC value is larger than 200, PWM duty cycle is 75% and 7-segment display will show digit 1. In the second condition, if ADC value within range 101 to 199, PWM duty cycle is 50% and 7-segment display will show digit 2. And the third condition, if ADC value is 70 to 100, PWM duty cycle is 25%, and 7 segment will display digit 1. If ADC value is lower than 70, PWM duty cycle is 0%, and 7 segment will display digit 0. So the loop is continue until the power is off. This is the program code that I already written. In the MP lab, you need to configure the header file first. This is the PWM function, ADC initialize function, ADC read function, and the main program that I explained before in the flowchart. And this is the Y1 loop. This is the ADC value that will be compared into 4 conditions. So after done doing this, we need to click this button, build, and then it will appear build successful, so that you can add the hex file to the process for the simulation. So let's see the circuit. When I attach this oscilloscope to see the PWM duty cycle, so when LDR sends no light, so 7 segment display will show digit 3, and lamp bright at maximum brightness. And this is the 75% duty cycle. So as LDR detect more light, 7 segment display will change value from 3 to 2. You can see this is 2, and this is 50% duty cycle, and lamps light up at medium brightness. So when LDR detect more light, it change to 1. And this is 25% duty cycle, and the lamp become dimmer. If LDR detects maximum light, the duty cycles become 0%, and 7 segment display shows 0 digit, and lamp will automatically turn off. So this is how our projects works for front yard lighting.